Okay, so in this question, I'm going to find the inverse z transform using a partial fraction expansion. Okay, first for this xz, we're going to define something different. We're going to define a function called fz. Okay, fz equals to x, capital Xz divided by z. Okay, so it's equals to 1 over 3z squared minus 4z plus 1. Okay, and we're gonna do a partial fraction on this. Okay, so the denominator here should be able to be in make into this a minus z minus a, z minus b kind of form. Okay, so this one is actually z squared minus bz minus az and plus ab. Okay, so it's actually z squared minus a plus b, z plus ab. Okay, so you can see that if you divide it every term by 3, then you have that equation, so you can find out how much is a and b. Okay, all right, so you can see that this one gonna equals to the square minus a 4 over 3z, okay, and plus a 1 over 3. So that means a plus b gonna equals to 4 over 3 and a multiplied with b 1 over 3. So then you can find that a equals to a 1 and a b equals to a 1/3. Okay, so then we can just make this f equals to a 1 over 3z minus 1 and z minus 1 z minus 1/3. Okay, then we do partial fraction. We make it something like this. We can make it a z minus 1 plus a b z minus 1 over 3. Okay, so to find out a and b. So this is a partial fraction. If you remember how to do that, a gonna equals to f z multiply with denominator here, z minus 1, and you're gonna plug this z equals 0, the pole of this term, and you can find the result. Okay, so this is let me write the full thing. So 3z minus 1, z minus 1 over 3. This is a minus sign, and this is fz, right? Multiply with z minus 1, which is gonna cancel this part, and you're gonna plug z equal to 0 in. So z equal to 0 equal to 1 over 3 multiplied with z minus 0 minus 1/3. Okay, so this one gives you, how much is that? Sorry, my mistake. Z is not 0, is 1, right? So z equal to 1. So this is the what's that called? That's the root for the denominator here. So it's 1 minus 1/3. So the result is 2/3 multiply with 3 and 1 over that, so it's 1 over 2. Okay, all right, so oops. Okay, so for part b, for b is same thing, fz multiply with z minus 1/3, and you're gonna plug z equals to 1/3. Okay, so I'm gonna skip that. You're gonna find this 1/2 here. All right, so the capital X Z gonna equals to half multiply with z over z minus 1. Okay, and another one is negative 1/2. Let me see if it's clear. Negative 1/2 multiply with z over z minus 1/3. Okay, so we could just put a and b in and multiply with a z, because fz is this one, so xz is fz multiply with a z. All right, so in this case we're gonna look at bring this one, because this in z domain we want to do an inverse z transform. I'm gonna bring it back to the time domain, so z over z minus a. If you look at the equation sheet, that this one equals to a n u n, okay, for positive sequence, okay, and equals to a negative a n u n minus, sorry, u negative n minus 1 is for the negative sequence. Let me shrink a little bit. Okay, for the negative sequence. Okay, so for part A, move down a little. So for part A, we know that the ROC is z smaller than 1/3. We did that in last question, so this is 1/3. Okay, so this is a negative sequence, so the result is lowercase n gonna equals to negative sequence, so negative 1/2, 1 to the order of n, u negative n minus 1 plus 1/2 third n u negative n negative 1. Okay, so for part B, it's a bit different. For part B, you see that for part B, the ROC is larger than 1/3 but smaller than 1. So if you draw that, is something like this. So this is 1/3 and this is 1. Okay, this is 1. So the region of convergency is outside of 1/3 but inside of 1, unit circle of 1. So in this case, for PO equal to 1 is a negative sequence because it's inside of this unit circle, this PO, number 1, okay? But for PO, 1/3 is a positive sequence, right? Because it's outside of this 1/3 unit circle. So for part B, let me move this one. For part B, we got xn equals to, this term is a negative, just the same as what we did in this one. And for The next one is positive. So positive, so negative 1 over 2, 1/3 n, and un. Okay, so that's for this question.